When you're solving equations with exponents or logs, first want the exponent or log to be by itself, then we're going to convert it. So when the variable's in the exponent, we're going to convert it to a log. Since the base is 7, we're going to convert it to a log base 7, because the base is the base. But then the exponent becomes the answer, and the answer goes with the log. So now we converted it, we can solve the equation for x, which is pretty simple, one step, divide by 3, divide by 3. We get x equals log base 7 of 20 divided by 3. So there's our exact answer, or the inexact form, log base 7 of 20 over 3. But to get it as a decimal, rounded to the thousandths place, we'll pull out our calculator. And we want log base 7, which you can either get to by going to option, calc, scroll over to log AB. And you can do base 7, comma 20. Remember, you can do it that way, or you can just type it in as log 20 divided by log 7. Either way, you get the same answer. So no matter which way you type it in, that's the top of our equation, log base 7 of 20. Divide that by 3 to get our final answer. So our answer, rounded to the thousandths place, 0.513. If the term that has the x and the exponent isn't by itself, then your first step is just to get it by itself. So if there's a +2 with, or if there's a -2 with it, we're just going to add 2 to both sides. So 20 to the x plus 3 equals 13 plus 2 is 15. Then we'll convert it to a log. So the base is 20, so we'll do log base 20 of 15 equals x plus 3. So to get x by itself, to finish this off, subtract the 3, we get log, or x equals log base 20 of 15, and we're just subtracting the 3. So that's minus 3. Then we'll pull out our calculator and do log base 20 of 15, and then subtract 3 from that answer. So since it's log base 20 of 15, you could do log 15 divided by log of 20. Or you do log AB. The base is 20, so that goes first, comma 15. Same answer because it's the same thing. So that's our decimal for the log. Then we had to subtract 3 from that. Minus 3. Round it. We get negative 2.096. So there's our exact answer and the decimal. Good. So the first step, we're going to add the 3 to the other side. We get negative, or 13 to the negative 2x equals 11. So we turn it to a log. We get log base 13 of 11. 11 equals negative 2x. So let's finish it off by just dividing by negative 2. So we get x equals log base 13 of 11 divided by negative 2. Then we can get our decimal approximation from the calculator. Log base 13 of 11. Base 13 of 11. Whoop, that's 111. Log base 13 of 11. Try that again. 0.93, about 5. I did it again. I typed it wrong the first time, so I did it again. Divided by negative 2 for our final answer. So negative 0.467. All of that. We have the exact answer and the decimal. First step this time is to divide by 5 to get the thing with the exponent by itself. So we have 3 to the 2x equals 21 over 5. Then we'll change it to a log, so we'll do log base 3, because the base is 3, of 21 over 5 equals the exponent, 2x. So our exact answer would just divide by 2. So x equals log base 3, 21/5 over 2. And we'll punch that into our calculator. Log base 3 of 21 over 5. Base 3, 21 over 5. You get 1.306. Finish it off by dividing by 2. So 0.653. So when there's 2 terms with an exponent with x in it, just pick one of them to do the log of, or you could pick another random log to take. If you just want to do natural log, you could do natural log because that would be less writing. But pick a log to do. I like to pick one of the 2 numbers that's involved. You don't have to do. So I'm going to pick log base 4, just like we did before. Whoops. So we just do the log to both sides. Do the log to both sides. So we're not converting. You just do log on both sides. So we write log base 4 on both sides. So in yesterday's notes, we talked about how when you have a log, the exponent can move to the front. The exponent can move to the front. So log base 4 of 4 with an x in the front. Move this exponent to the front also. We get 2x plus 1 log base 4 of 3. So now we got to finish this off. Log base 4 of 4, whenever the base is the same as the number right next to it, they cancel out. That's a 1. So this is x equals 2x plus 1 log base 4 of 3. So the main thing to remember is that even though this is weird looking, log base 4 of 3, it's a number. We could get that number from our calculator if we wanted it. We just don't want it yet. So we're going to distribute that log base 4 of 3, whatever that number is, we're going to distribute it. So we get 2x log base 4 of 3 plus 1 times log base 4 of 3. Now, anytime you have an equation with x's in multiple spots, you need them on the same side of the equation. So let's move the 2x log base 4 of 3 over. Since there's an x in both terms on the left, we're going to factor out an x. So you're left with 1 minus 2 log base 4 of 3. So here's x all by itself. We just got to get rid of this other stuff by dividing. That will cancel out. So we're left with x equals this. So we can also change this to a decimal by punching it into our calculator. So we need log base 4 of 3 base 4 of 3 divided by, and then just make sure you do parentheses because it was 1 minus 2 log base 4 of 3. So there's our decimal approximation, negative 1.355.